creator of the C4 model, not from England, not from UK, not from Great Britain, but from the Crown Dependency of Jersey. Simon Brown, welcome.
Thank you very much. Thank you very much, and good morning, everybody. So yes, I'm from the island of Jersey. This may have given away my first slide. So the code doesn't tell the whole story. It turns out the documentation is quite important these days, but it's something that we're not very good at in the industry, to say the least. So imagine the year is not 2022, which I think it is, right? I know the years have gone a bit weird in the past couple of years, but imagine it's actually 2122, and we finally invented teleportation. And I teleport us all to this spot. You open your eyes. Do you know where you are? Not really. How do you solve this problem? You've been dropped in this very pretty looking leafy lane. It's a bit overcast. How do you fix this problem? How do you figure out where you are? Well, you have a couple of options. Now, option number one, you walk up this road and you hopefully run into a dog walker. And you ask the dog walker, excuse me, I've just been teleported here, and they look at you a bit strange. Ignore that. Where am I? The response you're going to get back is either very general or very specific. They're probably going to say, oh, you are on La Rue du something. And your response is going to be, okay, but where am I? Like, I'm still lost. I don't know where this is. So how do we fix this problem in the real world? Well, option two, you get your smartphone out. Hopefully smartphones still exist in 2122. And you open up some Maps app, and you press the little Find Me button, and it says, oh, here you are. Okay, so yes, we are on La Rue du Montpellier. Sounds very French. But where are we? How do we fix this problem in Google Maps or something? We pinch the zoom out. There we go. So there we are. Now we're somewhere in Jersey, quite close to where I live. Anybody been to Jersey? Scanning very slowly. Oh, one person at the back. I'm surprised because when I was growing up as a child in Jersey, we used to see lots of Swedish people walking around with backpacks, saying that. So we used to have lots of language students come over to Jersey, which was quite fun. So Jersey is known for a few things. The STS thing, Bergerac. Anyone know Bergerac? Yeah, see, there we go. Jersey cows, Jersey potatoes, and there's some things with tax that we don't talk about. So going back to the map of Jersey, that map of Jersey had quite a lot of detail. It was the satellite imagery, of course. So, of course, something we can do in Google Maps is we can remove the satellite imagery. And now we get a slightly clearer picture of actually where we are. And this diagram is a bit better, this map's a bit better, because now we can see the intricate network of lanes and roads that allow us to link one spot on the island to another. Now it's kind of obscured by the satellite view of the world. Do you want to know where Jersey is? Some of you might do, some of you might not. How do you fix this in Google Maps? You zoom out again. So now we can see there's another island next door called Guernsey. We don't talk about them too much. But this is the coast of France on the right-hand side here. Which part of France, though? Again, zoom out a bit further. Oh, okay, so now we're between France and the UK, /England, /Great Britain, or all those other terms. And if we keep zooming out, Jersey starts to get quite hard to see. It's like only a couple of pixels now, and if we zoom out a bit more, it's gone. It's only a tiny island, 15 kilometers by 10. So if you ever do want to come to Jersey one day, when you pass through the harbour or the airport, you'll generally see a big stack of visitor maps waiting for you to pick up free of charge. And these visitor maps give you enough detail to start exploring our lovely little island. Make sure you come over in the summer, because in the winter it's a bit windy and rainy. You open up the visitor map, and it looks like this. And this is a nice simplified map. It's got most of the major roads and place names. It's more or less accurate. It's got some sites and some points of interest. You flip it over, and there's a zoom in on the town centre. And again, this is mostly accurate. Now you can see some street names in the towns, and you can figure out where the car parks are if you've rented a car. And you can find where some of the beaches are and things like that. Again, it's mostly accurate. Why do I say mostly accurate? So you see this thing here, this blue thing. So this is the beach. We have this blue thing here, which is labeled bathing pool. It looks like you can walk down the beach and jump in this pool and go for a swim. And you can, at low tide. At high tide, there's no beach. It's all water. And this map doesn't tell you that quite important information. And this is important information, by the way, because, where am I? There's a slipway, a little slipway you can drive down here and park your car. If the tide comes in, your car goes floating. And that happens every summer. We see it on the news. People lost their cars because they don't realize we have so much tide. So that's one type of map. Contrast that with like an ordnance survey map. So this is a very detailed, very specific map. It's created with lots of measurements and photographs and maybe drone photography these days. It's very precise. There's lots and lots of information on here. And this map actually does tell you the difference between the low tide marks and the high tide marks. So it's much more detailed, but of course it's a little bit more sophisticated. You need a little bit more information to read and understand this thing. So really it's different maps for different audiences and different purposes. So what has this got to do with anything? Well, the thing I find funny about the software development world is that we've spent the last 20 years figuring out how best to visualize our process. Scrum boards, Kanban charts, Trello, Jira, you name it. We've spent tons of time and effort and money building all these wonderful looking things with sticky notes and index cards, trying to figure out how we move things through our backlog of tasks, etc., etc. And that's kind of wonderful, but we've totally forgotten how to actually visualize the stuff we're building. So I get to fly around the world and do architecture workshops and diagramming workshops, and I see some absolutely horrible architecture diagrams. It's just not a skill that we kind of teach people anymore these days. Now, of course, things like UML exist, the Unified Modeling Language, and the Unified Modeling Language is supposed to be one of the standard ways that we as software developers and architects share our ideas and communicate with one another. So who uses UML here? I'm going to have to scan slowly again, aren't I? There's like a handful of people, maybe half a dozen. And that's what I see in most places these days. Most people don't want to use UML anymore for a whole bunch of reasons. I've heard literally every reason you can possibly imagine. People have said to my face, if you use UML here, you'll be seen as old and old-fashioned, which I kind of took offense to. People have historically said the tooling's horrible and the tooling sucks, and there is some degree of truth there. If anybody remembers Rachel Rose, you had those yellow boxes with the purple pink borders, and it just looked horrible. People say it's a very elaborate waste of time, it's not expected in Agile. There's a whole bunch of reasons that people push out for not using the Unified Modeling Language. The last one's interesting. The value is in the conversation. I hear this from lots of Agile teams. The value is in the conversation. We don't need to spend so much time creating diagrams. The conversation is the important part. The diagrams are just the transient thing we use to have our conversations. I mean, that's great, but what happened when everybody started working from home? Awkward. Guess what? All these companies had no documentation, no diagrams anymore, and people were struggling to scale their ideas. So the whole just use a whiteboard thing, I'm a big fan of whiteboards as a way to do collaborative software design. So it's a nice big space, we can get our ideas out there quickly, we can iterate. So I think a whiteboard is a fantastic tool, but much of the advice you see these days about just using a whiteboard is not going far enough. A whiteboard, by definition, is a blank canvas. It gives you no structure, no rules, no guidance. And that's why many organizations end up with diagrams that literally look like this. It's just a mess of arbitrary boxes and arrows. And of course, UML fixes some of these things, but if you don't want to use UML, you're back to this. And so really my advice for these teams is, well, if you do want to use boxes and arrows, and you really don't want to use UML and Archimate and SysML and other formalized notations, try to do so in a structured way. And make sure your diagrams use a self-describing notation. And of course, one of the things we have to take into account here is that we have different people on our teams, different people in our organizations. Some are very technical, us as developers and architects and infrastructure staff and technical testers, and some are very non-technical. Your non-technical testers, product owners, scrum masters, et cetera, And we need to cater for all of these different audiences because we want to be able to tell them different stories. And this is exactly why I created my C4 model for visualizing software architecture. You can find more information about this on c4model.com. But the C4 model for visualizing software architecture is essentially two things. It's a set of abstractions, a set of hierarchical abstractions, software systems, containers, components, and code. not Docker, sorry. And it's a set of hierarchical diagram types. There's a system context diagram, a container diagram, a component diagram, and a code level diagram. And that's it. It's a nice hierarchical set of diagrams. By container, I basically mean an application or a data store. And you can use these various levels of diagrams to tell different stories to different audiences. And the concept here is exactly diagrams as maps. So if you do a search for Jersey on something like Google Maps, you're going to get this third picture up here. Google Maps is going to say, oh, Jersey, make Jersey as big as we possibly can. This is great if you want to know where the airport is and where the beaches are and where the major roads are. But again, if you've never heard of it, it's too much information too quickly. How do you fix this? Pinch and zoom out. On the flip side, you can zoom in, zoom in, zoom in, and eventually you'll drop down to Google Street View. And Google Street View is a one-to-one mapping with reality when the photographs were taken, of course. And I want to do the same thing with software architecture diagrams. Imagine you join a new team, a team you've never worked with before, and they have 1 million lines of code. And they drop you in that 1 million lines of code and say, just go add this feature here. It's like throwing you into Street View. You're like, what? Like, this is too detailed. I don't know what this is. I don't know where I am in the code base. I don't know what I'm doing. I need some context. I need the why and the what and the rationale. So you want to zoom out the code base to show something a little bit higher level. And the C4 diagrams give you that. The C4 model itself is notation independent. So all of the examples you might have seen me present in the past have all been blue boxes, and many people have mistaken that for thinking that the C4 model equals blue boxes. That's not the case. But you can use any different colors, any different shapes, and you can even use UML if you want to. So the C4 model is completely notation independent, and it provides a way to plug in other notations in the future if you want to. In terms of the diagram types, the top level diagram, the system context diagram, in order to draw this diagram, you have to ask and answer a bunch of questions. For example, what is the scope of the software system we are building or designing or describing? So the C4 model is something you can use during a design exercise or for retrospectively documenting existing systems. So what features live inside the system boundary? Who is using our system? Who are the roles, the actors, the personas, the real named people who are using and interacting with our system? And what are they doing? What sorts of features do we need to provide and support? And what system integration points does our system have with the outside world? Maybe inside our environment or outside of our environment. So once you ask and answer those questions, you can draft up a system context diagram. And this is an example system context diagram from one of my workshops. The red box labeled financial risk system is the system that this group were designing. They've identified a couple of different user types, and the other black boxes around the edge represent the existing systems that already exist in the bank that this thing needs to connect to. So it's a really nice high-level diagram that you can use to describe this system to lots of different audiences, both technical and non-technical. Of course, as technology people, we're kind of itching for more techie details, so now we can pinch to zoom on this box, and we can drop down to level 2 and draw the container diagram. By container, I basically mean an application or a data store. Feel free to grab me during the break if you want to know why I chose the term container. The container diagram shows applications and data stores, and essentially what you're doing is you're answering that first question. What are the major technology building blocks that we are going to be using to implement our system? What are the responsibilities of those building blocks? So what do the applications do? What data do the data stores store? And how do these things link up at runtime? How do they talk to one another? Answer those questions, and you can draft up something like a container diagram. So here we have the red box. That's the red box in the previous picture, of course. We've identified a couple of UIs at the top, some command line apps at the bottom, and some data storage things in the middle. So that's really the C4 model in a nutshell, and how I kind of relate it back to the diagrams as maps thing. Although the C4 model is notation independent, I still have some tips and guidelines on what I think a good notation should look like. And I have a notation checklist you can find on my c4model.com website that you can quickly go through, answer yes or no, and it will hopefully give some hints and tips on how you can create a better diagram notation. And really, the diagrams are maps to navigate your code base. With a small code base, you might not need this. With a large code base, you most certainly do, to some degree anyway. Now, the thing these maps all have in common, if you remember back to the visitor map and the ordnance survey map, the very detailed one, the thing these maps have in common is points of interest. And if you think about most code bases out there, all quite boring. Like imagine you've got 1 million lines of code and your system is doing 1,000 different features. Are they all interesting? Probably not. Maybe you've got like 900 features which are all kind of the same, all CRUDs, data in and out of a database is all very boring. But maybe there are a handful of things that are actually quite interesting. Or maybe there's a specific pattern that's being followed in your code base that's quite interesting. So maybe this is how you figure out what to tell people about your code base. What do you think the points of interest are? Now, going back to my Jersey story. So you have the island of Jersey, and then off the south coast of the island of Jersey is another smaller island. And on that island is a castle called Elizabeth Castle. And this is a fabulous example of one of these kind of old granite castles. It was started to be built in 1594, if Wikipedia serves me right. And it's a really nice little day trip. You can either walk out there when the tide is low. There's a little path and a causeway from the beach right out to the castle. And when the tide is high, you have to get one of those little kind of amphibious vehicles, which is quite cool. And when you're walking around this castle, you get to the middle, and there's a natural high point, as there might be in a castle. And there's a big house, and it's beautiful. It's all made of granite and big granite walls, and it's stunning stone walls, and it's lovely. And as you get closer and closer and closer, you're like, what is that on top of this beautiful granite castle? Like, why is this horrible round concrete thing stuck on the top of this beautiful granite castle? Anyone know the answer? World War II, right. So Jersey was one of the places in Europe that was occupied during World War II by the Germans. And because this castle has been built in such a good place, for obvious reasons, you can see almost the entirety of the south coast, the Germans thought, yeah, let's build more guns. And they did. And they did this at various points around the island. How do you learn this? I mean, you can have a guess. You can think, oh, I think that's something about World War II. But there's a whole bunch of signs dotted around the castle that tell you more about the history. So that's one option. Anyone have kids? Yeah, you're not going to have time to read this. Trust me. I've taken my kids when they were little around this castle. They're like, Daddy, Daddy, more guns. We want to see guns. I want to read the signs. No, guns. Okay. Take photos, read them later. Your other option is when you're flying or getting the boat to Jersey, you pick up a travel guidebook. And hopefully the kids are having a snooze, and you get to flick through the travel guidebook as quickly as you possibly can. And the travel guidebooks are great. They're nice, lightweight books, maybe 100 pages. They contain a bunch of maps. What do maps help you do? Navigate an unfamiliar environment. They have a bunch of points of interest. They'll talk about the castles. We have a bunch of castles and things in Jersey. They'll tell you about walking itineraries and walking routes. We have lots of cliff path walks you can take, and it kind of links all those together, cycle tracks, etc. It tells you about the history and the culture. So Jersey's got quite a varied history for such a small island because the Germans were there, and the British and the French were always fighting over it, etc., etc. And there's all the practical information about power and currency and how to use the buses and all of that type of stuff. So you can grab a travel guidebook, or you can maybe just download one on your mobile device. When you're walking around the castle, you're looking at the beautiful granite stonework and the bricks, and these don't tell you the whole story on their own. You need the science to tell you what the history is and why the castle was built in the way it's been built. You can't get that from looking at the bricks and the materials on their own. And the same is true with software. You jump into that code base of 1 million lines of code. You can work out a bunch of stuff. It's going to take you some time, but the code doesn't tell you the whole story. The code is like a snapshot of now. But of course, the code has evolved over a number of years, maybe a number of decades in some cases. And there's a whole bunch of reasons and rationale that have been lost over time, unless they're written down, of course. So how do we write things down in software? we wheel out our good old-fashioned friend, the software architecture document, aptly known as the SAD. Yep. Because that's exactly how you feel when you write or read these things. Now, I like the concept, like every methodology you've ever seen in the past has had their own special type of SAD. Every consulting company I've worked for has their own special type of sadness as well. There's lots of good stuff that's supposed to be in these things, but the implementation leaves something to be desired. They're very heavy, they're very boring, they're very dry, and they're not updated. And people will often say, well, out-of-date documentation is worse than no documentation. Do I agree with that? I'm not so sure. So how do we take these concepts and create something a bit more exciting, a bit more lightweight, something that people might want to read? Well, let's do the guidebook thing. So let's craft up something like a software guidebook, a nice lightweight piece of documentation that has a bunch of maps. What are the maps? The maps are the diagrams, the software architecture diagrams, the C4 diagrams that help you navigate a complicated code base. They give you a jump-off point to start exploring. The software guidebook is also going to tell you about these points of interest. What's really interesting in our code bases? What are the tricky, complicated bits? What did we spend lots of time thinking hard about? Let's detail that important stuff. Let's give people a tour, maybe. Let's tell people about the history. How did our million lines of code get to be where it is today? What was the path of evolution for that code base over all those years? And where does it run? Who looks after it? Where is the source code? How do we build it? Where do logs go? Let's talk about some of those practical things as well. And what I'm really doing here is I'm crafting up a software guidebook to describe a single software system. So remember that red box from the C4 diagrams I showed you? I want a piece of documentation that describes that red box and how that red box works and how it came to be. And my tip here is that your documentation should basically describe what you can't get from the code base. If you go back 20 years ago, we had this tendency to do big design up front and write tons of documentation. And certainly I worked on projects where before I was even allowed to write a line of code, I had to submit a document for review. And that document would have a bunch of class diagrams and a description of the code I was going to write, and maybe pseudocode, and maybe a list of all the test cases I was going to run manually. Well, we don't do that anymore because we have a whole bunch of other techniques to essentially accomplish the same thing in an automated fashion. But still looking at a code base, there's a bunch of information it doesn't tell me. How did the code base get to be where it is today? So what do I have in my software guidebook? There's a number of ways you can look at this. Here's my template. It's just what I call the software guidebook. I'm not going to talk about all these sections because, documentation is kind of boring, isn't it? But these are the types of things I generally have in this software guidebook. It's telling me something about what the system is and how it fits into the world around it. It's telling me something about the things that drove the architecture decisions we ended up making, the important requirements, the important quality attributes, your scaling, security, performance. It's telling something about the constraints of the environment that led us to this point, and it's telling us about the set of principles that we as a team follow when we're building this code base. I want to describe my architecture at different levels of abstraction. That's where C4 comes in. I might want to talk about specific code highlights. I might want to talk about specific data highlights, maybe data schemas and entity relationship diagrams if they're useful. I might want to talk about infrastructure and deployment architectures. I might want to tell people very clearly how to set up a development environment. And I might want to tell something about operation and support aspects. So that's the kind of information I'm looking to include in my software guidebook because it's stuff that's not readily available just from reading the source code. If you want to know more about this, I have a book you can grab from LeanPub. We'll make the slides available after. If you go to this URL, you can basically buy this book for $0. And all of the sections I've just described are elaborated in more detail in that book. Another variation or option on this theme is called ARC42. ARC42 is another lightweight software architecture document template. It's predominantly used within Germany and the German-speaking countries, and it's not really got out of that bubble yet. And that's just a historical thing, because much of the original documentation for ARC42 was in the German language, And so that's why it's kind of stayed in that bubble. But it's all now in English. You can find ARC42 very easily on the internet. And it's the same type of thing as my software guidebook, just with different section headings in a different order. So I'm more than happy to recommend you go look at ARC42 as well. In terms of the diagrams, there's a section here, section 5 is called the building block view. Most people put C4 inside the building block view. So there's a nice way to tie all these things up as well. One of the questions I always get is, well, how do we write these things? Like, what format should we use for documentation? And historically and traditionally, this has been Word, SharePoint, Confluence. And I still see lots of teams doing that today, of course. But I see more and more teams adopting for lighter weight documentation as text, docs as text formats, like Markdown and ASCII doc. And then they include these things in their source code control system next to their source code. So you have your documentation as code and your code as code in the same place. And then you have a build process that generates HTML microsites, maybe uploads it to Confluence pages. There's a whole bunch of interesting stuff you can do with a kind of docs as code toolchain. And there are tons of tools out there on the internet to support that workflow. The other major question I get, of course, is, well, how long should documentation be? And people are normally looking for how many numbers of pages is good? And that's a silly question to ask, isn't it? Because it depends how big and complicated your system is. I've worked on systems where the software guidebook has literally been 10 pages. And that's it. That was sufficient to describe the whole code base. But I've also been on systems where we've needed 70 or 100 pages because we've got very complicated security requirements, for example. So I once worked on an internet banking system. That's a good example where we had to write lots of stuff about security. So how long should these documents be? Think about it like this. Imagine you join an existing team, they have an existing code base, and you know nothing about it. I think if you have a piece of documentation that you can read in 1 or 2 hours with a couple of nice cups of coffee, and that gives you a good jump-off point to exploring the code base with more information, I think that's a really nice set of documentation. So in real terms, yeah, how fast can you read? Maybe it's 50 or 60 or 100 pages maximum, but not these huge tomes of things we used to find with the software architecture documents. How do you keep these things up to date? Yeah, that's a tricky question, isn't it? This is one of the things that people struggle with. How do we keep documentation up to date? You have two options. Option number one, automate everything. So make sure that you generate absolutely every single part of your documentation. Is anybody doing that? No, because it's really hard. It turns out that if we have 1 million lines of code, it's really hard to kind of write some tooling that analyzes that 1 million lines of code and creates you some decent human readable documentation, because the code is at the wrong level of abstraction. And as humans, we're very good at kind of bundling stuff together and grouping stuff together and abstracting things and coming up with a very simpler mental model of how we look at that system from a top-down perspective. So maybe in the future we can automate things, and of course we can automate some amount of documentation. We can automate some of the lower-level C4 diagrams. We can automate things like API definitions and contracts, but some of the more general documentation is a little bit harder to automatically generate. So that really leaves option 2. And option 2 is just keep it up to date. Like, that's it. There's nothing more complicated than that. One of the things I recommend teams do is if you have a definition of done for your tasks and your work items, just add a line to the bottom. Have you updated the diagrams and the documentation as a part of this package? If you're doing pull requests, make sure you review the diagrams and documentation. If it's not done, reject it. Now, I'm not naive. I know exactly what's going to happen when time gets tight. We're like, yeah, we'll skip that. We'll do documentation later. Of course we will. But you have to apply some discipline here. And these documents are constantly evolving things. So go back 20 years ago, there was this temptation that when we crafted up a software architecture document of some description, we would baseline it, finish it, finalize it, get it signed off and reviewed by 20 different people who had no interest in our project, and then we would never touch it again. That's not what we're trying to do here. For me, you're evolving your code base when you're adding new features, and you're evolving your documentation and your diagrams when you're adding those same features. So this is something we're trying to keep up to date as we go along. And what you tend to find is that once you keep these things up to date continuously, it's lots of small changes, and that's a much easier thing to manage than one person staying behind when the project is done to kind of write 100 pages of documentation. It's also a really boring task. The other reason we want to keep these things up to date is because we're always making decisions, aren't we? We're adding features, we're making decisions, maybe we're changing our architecture, maybe we're evolving our architecture, we're emerging our design as we go along. We're reacting to change, we're embracing change. So maybe we need to keep our documentation up to date from that perspective. And that's why having a log of the major decisions is also a useful thing to add in your documentation set. Historically, this has been a section at the end of the document, writing out all the decisions, but I see more and more people these days leaning towards kind of free format text definitions, and more specifically things like architecture decision records. An architecture decision record, you can find the details here. Michael Nygaard is the person who kind of popularized this thing. It's just a structured way to document a single decision that we're making as a team. Every decision has a title. Naming's hard, but hopefully a nice, meaningful title. Something about the context of the decision, so why were we making this decision? A description of the decision itself. A status. The status is really interesting. Is this a decision we are proposing the team goes forward with? Is this a decision we have accepted as a team and we're all following it? Or is it something we are deprecating in favor of a better decision, or maybe we're superseding an old decision and we've come up with a new version? So there's lots of ways to think about statuses here. And this is a great way to stop people doing the wrong thing. Imagine you look at a code base and there are 4 or 5 ways to do the same thing. Which one is the current way? Where you look in your decision log, oh, we deprecated these 4 ways and now we're on way 5. Right, now we know what we're doing. And finally, something about consequences. It turns out something about consequences is really useful here, because no decision is trade-off free. There's no silver bullets. There are good things and bad things about any decision. And sometimes writing those things down is a really useful thing to capture, because then, guess what? You won't reinvent the wheel in 3 years' time. You go, I remember why we made this decision. It does all this good thing, but this one thing we didn't think we needed at the time, guess what? Now things have changed. In terms of what decisions are we trying to record, it's not all of them. We're not trying to make and record every single decision. Imagine if you did that for your 1,000,000 lines of code. Every time you renamed a class, let's write that down as a decision. Oh my goodness, you'd have so many decisions, so many text files in this folder. For me, it's about the major decisions. What do I mean by the major decisions? Well, it's about the architecture decisions. What do I mean by the architecture decisions? Grady Booch, one of the co-creators of UML, has a great blog post that talks about the difference between architecture and design, and he essentially says this: architecture represents the significant decisions where significance is measured by cost of change. And I really like this as a way to think about the types of things we want to be recording in our decision log. We make a bunch of decisions. Some of those things are hard to change. The programming language we're using. So we start with an empty folder. We start typing Java code into that folder. Guess what? We just made a decision to use Java. A few weeks go past, we now have 2,000 lines of Java code. Now we can't easily change that to another language. We're going to build a single monolithic application. That's a significant decision. Now we can't easily change that to be a set of microservices. Or vice versa, we start out building a set of microservices and then maybe in 3 years we want to collapse it back to a monolith. Well, guess what? The significant decision we made 3 years ago was to use microservices architecture. And some of those frameworks and libraries that become embedded in your code base, those are things we want to describe as well. So this is a great way to think about the types of decisions you want to be thinking about and therefore recording. Martin Fowler on his Blicky also said the same thing long time ago. I think there's a role for a broad starting point. Architecture, such things as stating earlier on how to do layering. So again, talking about code structure and principles and how we as a team are going to structure our code base, whether it's package by layer, package by feature, package by component, et cetera. How we're going to interact with the database, so anything around data tends to be significant, of course, and how we're going to handle web requests. So same type of stuff here being echoed by Martin Fowler. Is anybody using architecture decision records here, by the way? A couple of people. So I definitely urge people to go and start looking into architecture decision records. Bunch of Markdown or ASCII doc text files. There's a bunch of command line tools to help you support and kind of manage these things as a collection of files in a folder. I started doing it myself a few years ago for some of the systems that I'm working on, some of the systems that I own. And it's really fascinating to kind of go back through time and look at some of the early decisions I made and just read the decisions because they're only this long in a text file. And reading some of those decisions kind of like brings back all those memories. Oh, I know where I was at the time, and these were constraints, and it's really interesting. The thing I'd urge people to do is make sure these decision records don't get lost. Because if you have a bunch of decision records in a folder as Markdown in source code control, they're a bit hidden. You kind of have to get these things out and do something with them and kind of manually open them. So I'd recommend teams look at exposing and publishing and visualizing the architecture decision records as well. So this is a screenshot of a visualization of my architecture decision records for one of my products. And you can see we've got a whole bunch of decisions, all have different dates. We've got a summary of the status here. We can see that this one over here has been superseded. It's a really nice way to kind of visualize these decisions and to let people kind of search through them. You'll notice if you scan your eyes down this list on the left-hand side, they're all quite major decisions. It's services we're using. It's not code structure and renaming and those sorts of smaller things. It's kind of quite big, chunky decisions here. You'll notice this thing here, use Taxamo for VIT validation has been superseded. What's it been superseded by? Build yourself a graph. This is a graph visualization I built on my architecture decision records. And now what you can see here is that I started out hosting one of my cloud services, one of my products on Rackspace, kind of like a build yourself your own servers, manage your own servers. And then after a while, I switched to Pivotal Web Services Cloud Foundry. So Pivotal Web Services Cloud Foundry was a great public service where you could just push a Java app and magic happened and it worked and you had it on the internet. And at the same time, I was using ClearDB as my data store because ClearDB was kind of provided by Pivotal Web Services and it was super easy to set up and use and configure. And then guess what happened? Pivotal Web Services Cloud Foundry got shut down. They discontinued the thing. So I couldn't keep using and hosting my app on Pivotal Web Services. So now you can see I've superseded those decisions, and now I'm running basically everything on ECS in Amazon Web Services, and I'm using MySQL on Amazon RDS in Amazon Web Services. So again, this graph is a really nice way to kind of track that set of decisions and how they've evolved over time. And I think this is super useful. One of the questions I always get about ADRs is, should these things be mutable or immutable? And for me, the kind of default way to use ADRs is as immutable text files. So you craft up a decision, and the only thing you ever change is really the status. If you make a decision A, and then you change your mind 6 months later, and you craft up decision B, you mark A as superseded by decision B. You don't change the decision A, that first record. There are some teams doing that, so they have a single decision record. They put that in source code control. When they change that decision, they change that decision record and check it back into source code control. The theory being the history of that decision is now in source code control with diffs and things. And they're right, it is, but it's a bit harder to find and you can't do those nice visualizations easily. So my recommendation here with ADRs is make them immutable. And people say, how do we make our architecture diagrams show decisions? And the answer is you don't. You have your decision records showing and recording your decisions, and your architecture diagrams are showing the results of those decisions, the outcomes of those decisions. It's the end state of those decisions. So in summary, over the past 20 years, we've thrown away big design up front. Hooray! There's lots of things wrong with big design up front. It's very speculative, it's very wasteful, we all know those things. However, many teams have also thrown away stuff like how to think architecturally. They've thrown away documentation and diagramming and things like architecture modeling. Why? Because many teams associated these things with big design up front, and when they throw that away, they throw all the other stuff away as well, which is kind of unfortunate. So what I want to do here is I want to bring back some of these techniques, maybe in lighter formats, kind of lighter practices, lighter weight practices, because I think they're useful. This is what the Agile Manifesto says, of course, about documentation. We value working software over comprehensive documentation. These 5 words don't mean don't write documentation. But unfortunately, of course, many people take that shortcut and they claim this says don't write documentation, and then they get into a mess. And I think as software developers and architects, we have a duty to deliver something. Sure, we've got the code, and we can have clean code and readable code and code with intentful method names and variable names and all of that good stuff, and you should do that stuff. I definitely agree. But I think we have a duty as software professionals to deliver something else alongside our code bases. Something that describes what it is, what it does, how we got there, and how to look after this thing. I think that's our duty. Why? Because there's lots of tribal and siloed knowledge out there. Oh, how do we add this new feature? Go talk to that person over there. They know how that thing works. Great. How do I add this new feature? Oh, this person over there is an expert in that area of the code base. We see that all the time. And that's fine. You know, lean on our specialisms, lean on our areas of expertise. But what happens when the bus comes along? I mean, tears will be shed, of course, but that critical knowledge ends up walking out of your door. Or maybe they quit and you lose critical knowledge because it's not written down. And that is something that seems a shame in 2022. It's going to slow our teams down, and that's not something we're trying to do with our agile techniques, of course. So my summary. This is my holy trinity of lightweight documentation. You need a bunch of diagrams. The diagrams are really maps to help you navigate your code base. You have a set of lightweight documentation. The lightweight documentation describes what you can't get from your code. And you wrap this all together with a set of architecture decision records that essentially become your change log and sit underneath everything else. So thank you very much. If you'd like a copy of my 2 software architecture books, you can go to this URL and grab them for free.
It's a tradition to have a presenter's gift. For a number of years, we have actually not done that. Instead, we have used that money for charity, actually. Of the speaker's choice, this year we have rationalized and make this a bit more effective, efficient, perhaps. So we've chosen for you.
Cool.
So all the money which would have gone to speaker gifts will be given to 3 charities. It will be Hjärnfonden, supporting research in brain problems, illnesses. BRIS, protecting children in the society and their rights. And last but not least, the UNHCR's Ukraine initiative. So here's a small token of your contribution, not only to this conference, but also to the world. Thank you.
Thank you.